flexing the Flux, and what I'm going to talk about is a little bit of opinionated approach towards Flux. And what this talk is actually about is establishing the need for GitOps and where the Flux fits in the whole GitOps thing. And when we have established these 2 points, then next would be what choices we have made along the way, because in any implementation or tool, you sometimes pick certain ways to do things in certain workflows. So what this talk is not about is a tutorial or demo of Flux or GitOps in general, because the time is limited, and Flux, although is a simple tool, simple to understand, simpler than Kubernetes, but even still, it's not simple enough to be properly explained within 10 minutes, 15 minutes, or half an hour. So I'll be referring to documentation and other things. So of course, it's not a replacement for the official documentation. So the goal is a bit of an orientation and a gentle introduction to what the Flux is and how you can use it. And maybe the use case that I'm presenting is somewhat similar to your situation. So essentially 4 things: the need, the tool itself, our usage, and some caveats. So these are the 4 points that I'll be talking about. Okay, so speaking of Kubernetes, basically, I'll assume that people are aware about Kubernetes and have some, of course, idea because they're in the Kubernetes conference, but I'll still quickly recap to establish my argument and to put my case. So Kubernetes works with REST APIs, and these are all declarative kind of objects which tell the cluster to maintain a certain state, like run this workload, that's, and et cetera, et cetera. And such a mechanism, so if you have to deploy an application, it requires multiple such components, for example, deployment, service, config map, to store configuration secrets. And if you want to expose the service to the world, or within sometimes you would need an ingress, etc. So the question comes, what do you do of this state? This is a lot of objects, and these are YAML payloads to the HTTP call. One idea is to keep them in a local file system. So you see kubectl apply, and then I'm actually naming some files which describe the state that I want the clustering to be. But that again is not enough, because this is on your local system. It might get lost, or you might make changes that are very harmful, and you want to go back to some place back in the past. So how do we do that? So first idea is Git, put them in the Git. So that is the Git part. Next part is a single application is rarely deployed just once. There are variations of the same application deployed. For example, you have a single application that is deployed in the staging and production and the QA environment. And the deployment is pretty much similar, except minor details, CPU allocation, memory allocation, some of the other things change. Otherwise, the application remains the same. And the other problem is that in an organization, most of the applications again are deployed in a similar way. Not just that one application is deployed multiple times, but the multiple applications are deployed also in somewhat similar way. So this leads to a lot of repetition. If you have some 50 services which have all these 8 components each, then it just explodes. So what do you do? Basic idea is that because the objects are YAML, which is JSON, and which is just dictionary. So what you can do is merge them. You say, okay, this is my master plan, the main blueprint of the whole thing. And in the production, I want to deploy it. I just want to tweak a thing here, there, and here and there, etc. So it's just JSON merging or dictionary merging in any programming language. You can find library for that, would work. But there are some caveats to that if you do blind dictionary merge, and that's where this small tool Customize comes in, which understands the semantics of the Kubernetes API. So it does that kind of merging sensibly. So now what it allows you to do is to have a base and override few things downwards, a little bit of tweaks here and there. So you are safe from repetition. third thing, this is just an example. So I'm showing you this is a customization where it says the resources, the foundations are deployment.yaml, service config map, and then you say common labels, apply this common label to all. There are a lot many other options in customization. You can change keys, you can even transform keys, etc., etc. So I'll not go into the details, but the idea is that basically you can transform the JSON or the YAML from a base to something else. Now, the third thing also comes to rescue is that now what we have is that sort of YAML files which are versioned in a Git in a version control, and they are logically connected together. So when you deploy an application, it has a deployment service, ingress, blah blah blah, but they are not physically like they're not very cohesive, and that is what Helm fixes. It lets you group a bunch of manifests together as a single shippable unit. And you can think of it as like an npm package or apt package. When you install that, it brings all the things along it. So, but instead of those libraries and executables, it actually brings YAML manifests, or so to speak, Kubernetes objects. So you can bundle your application components together, and these packages are called charts. So just again, I'm repeating myself here that you can have an application chart which brings all the components, the deployments, the service, the cron job, etc. And it can be installed, it can be uninstalled, and it can be upgraded, etc. I'll just show a little example here. Again, Helm is a big topic, so you can refer to that. Here we see a chart of the WordPress. The WordPress is an application that can be installed on the Kubernetes. So this is the chart.yaml file, which is important, which describes the chart. And these are the templates which has all the objects that I talked about. And this is where I'm showing you the chart, which is kind of a manifest of what this is about. So now we have three tools under our belt. One is the versioned manifest, and then we have the ability to control the duplication. And the third, we talked about packaging together in a more cohesive packages. And the fourth thing is when you are versioning a thing in a Git repository, the problem arises is that what do you do of secrets? Because there are a lot many things, tokens and passwords, etc. So what to do about them? So there is also another open source tool called Mozilla SOAPs. What that will do is that given the specifications, it will encrypt the values of the keys that you give you. So here I'm just a short example. It says, okay, all the files that end in .yaml and have this key, it will match the regular expression, and all those values would be encrypted. Again, I'm not going into detail, but SOAPs is also very powerful. It can work with Amazon KMS and with Google and HashiCorp Vault, etc. So, or with the GPG as well. So now the bases are covered. So you have the Git to keep track of manifests, customize to avoid duplication, Helm to package things together, and SOAPs to encrypt. So now what? Now what is that? There should be a way to describe the state and sync it in the cluster. And that's where the Flux enters. Flux just does that. It pulls from a repository, applies the state to a cluster. That's it. It's that's the bare bone of it. And you don't make changes through kube control or through the Kubernetes API. You actually push changes through that Git repository that would be applied to the cluster. And hence, of course, the buzzword GitOps. So this is a short introduction of the whole the need for GitOps and what the Flux is. And Flux itself, still, I would like to talk about a little bit of anatomy of Flux for the uninitiated. Basic idea is that there are a bunch of controllers in Flux, and they are custom resource definitions. So there is source controller that just takes care of Git repositories, and there's customized controller which just applies these overlays that I talked about, and the Helm controller. And you create the CRDs, and the controller acts accordingly. And I think three of the most important are this CRDs are Git repository. You can define a Git repository, and Helm repository, and customization. So this much is all about Flux. Now I'll be talking about what our particular use case or usage is. So when we started replatforming our services, what we wanted was a simple tool that doesn't get in the way. We did not want something that brings notions and concepts of its own, because already there are a lot many concepts. There are manifests and there are Helm and there is customize and etc. So that's again, even for the applications, we have Helm packaging. We have a base chart, and the applications actually expand into their final form. So among many of the solution evaluated, we thought Flux is the simplest most, because it just does the thing that is already you would be doing manually, and it does not introduces any new concepts to that. And what we are doing here is that this is, again, I'm not just referring to that. I'm not going into the details, but the pattern here is, it's called Monorepo Pattern. The idea is that for every cluster in your organization, there is a directory in a single Git repository. So for all environments, we are a multi-cloud shop. So we have 3 major clouds all lined up. We have workloads on all 3 clouds, plus few regional clouds as well within Europe. So that's why this use case fits very well for us. And what in our choices, what we have left out, like I talked about earlier, that there are a lot many features. Flux is also able to pull images from your image registry. I think the technical culture, I'm not sure, we have talked about it, but we were not sure whether we should go out in that direction yet. And secondly, that's mainly, I have left it out. I'm not going to talk much about it. So these are our choices in Flux. But there are also some caveats along the way, and when we started to automate the whole thing, and that is that dependencies. You cannot put everything in the Git repo and install Flux and hope that it will be all synced. There are things that depends on other things, and if they are not created earlier, then the whole sync will continuously fail. So our lesson was that start with the secrets. In the first step, always provide all the secrets to the clouds, to the Git repositories, to image registries, whatever, or other API tokens. Just first round just patches that. Then the further round lays other foundations, like if there are certificates, etc., to be obtained, etc. Than that. And then third layer, you bring in the infrastructure place, like logging, monitoring, etc., and that gets applied. Basically, essentially, it's an open-ended territory. It's just like you refactor as you please, and you move around things. So as you start to apply these practices, you get to know better. So I'll show you a little bit of example of how we have done that. For example, this is an excerpt from this. So you can see on the right side, you see depends on secret. It is a customization, so to speak, which would be applied. But it says that it depends on secret. And the secret thing is actually this one, 01 secret. The 01 thing is just a naming convention that we adopted. It has no meaning in Flux, or it has no functionality. It does nothing. It just makes it easy at a glance to see, okay, what would be applied in what order. Otherwise, we would be scanning a bunch of YAML files to see what order the dependencies would be. So here, what happens is that first of all, the secrets get applied, and then the certificate manager pulls issues all the certificates that are required for the functional cluster, and then the infrastructure layer actually comes on top with the logging and monitoring and other components. And then at the fourth level, I haven't shown that, is the applications where the user-facing applications start to get rolled in. So this is probably, you'll also end up in a tiered approach towards applying the cluster state. So that's it. We are actually just starting out. We have a few clusters. We are in a transition phase, and we actually have used Flux 1 as well. So it was in a staging environment till a couple of weeks ago. and we moved it to Flux 2. Production was Flux 2, is Flux 2, but needs to be upgraded. So that is our use case. And I think we are pretty happy with the simplicity of Flux, and will be continuing to use it. So that's it. In summary, I just told about why you need a declarative cluster state management and what are the tools of the trade, where the Flux fits in, and some of the caveats and conventions. So thank you very much for your time. If there are any questions, please go ahead. I'll be waiting. Thank you.